So I'm Vincent, and I work for a company called XWiki SAS, and I also work for an open source project with the same name, XWiki. I'm a committer on that project. And we participated to a research project, a European research project for the past 2.5 years. And this research project is stamped as the blue icon you see on the screen. And during this research project, we worked on amplifying testing. That means starting from existing tests and generating new tests from existing tests. And as part of this work, we work on a subset, which was configuration testing. So configuration testing is about taking your functional tests, but running them into different configurations. So we'll see how it works. But I suspect that all of you are now used to writing functional tests, automated functional tests. And so we wanted to go a step beyond that and to execute those in various configurations. So we'll see what we mean. First, the use case, XWiki. So XWiki is a web app. And it's made of 3 components, 3 big parts. There is the database. There is the web app itself that runs into a servlet container, and the browser. So, so testing various configurations means testing various databases, various servlet engines, and various browsers. That's what it means for XWiki. It can mean different things for different projects, of course. So more specifically, for XWiki, we wanted to test with different versions of MySQL, different version of Postgres, HyperSQL, and a lot of others. Different drivers, different servlet containers like Tomcat or Jetty, different browsers, Chrome or Firefox, and other configurations that I'm not listing here. So if you do this matrix, that's a lot of different configurations. And if we want to make sure that our software runs for the users to download and use it, well, we need to verify that it does really by automating our tests. Before we started this project, we were running automatically on only one configuration. And through this experiment that we started, we're now running it on something like 25 or 30 different configurations. So how do you implement this? So the general solution is using Docker to isolate each part, to isolate the database part, the servlet engine part, and the browser part. So that's easy, but there are lots of ways of doing this. You could do it, for example, at the level of the CI. If you use Jenkins, there's a Docker plugin that you could use to try to do this, but it has some drawbacks. Like, for example, if you do that, then you're not able to test the various configuration on your laptop, on your developer laptop. And there are other solutions, like at the Maven level. There is a Maven plugin for Docker, which allows you to also start and stop containers and even create images from Maven. But again, we found that it was not ideal because it's not very easy, for example, to put breakpoints in your code whenever you run the code in a given configuration. So we wanted something that executed on your laptop. So you would be able to simulate any configuration and run that on your laptop, but also be able to debug your software in your IDE. So we found one little tool, one library that exists, and that's called TestContainers. And I've put on the screen an example of the documentation of TestContainers. It allows you to easily control Docker from your tests, from your unit tests. In this example, it's based on JUnit 5. And if you look at the example, it says there is an @container annotation. And in this example, it says that a new MySQL container. So what this means is that it will start and stop a MySQL container before and after tests. There is also the same with Postgres here. So that's a very generic ways of running test containers. But what we did is we extended it and created some annotations. So we had, before doing this, we had our Selenium-based tests existing. We had a lot of them. So we wanted to make it very easy to run exactly the same test, but with a different configuration. So we introduced an annotation at UI test, and then we have several parameters in which you describe which database you want, in which version, which servlet engine, in which version, which browser, etc. So what I propose is to show you how it works. So I'm in the IDE here. What I'm going to do is zoom a bit. So that's an example of a test, a real test, menu IT here. And you see for this test, I have configured Tomcat 8, latest version of Tomcat 8, with later version of MySQL 5. We're on Chrome, and I've put offline because I wasn't sure about the Wi-Fi here. So it's not going to download anything. And here I have a test. And if I run that, yes. So it's going to take a while. So what does it do? So it notices that XWiki is not started, because if you want for a fast turnaround trip, you can also start manually XWiki before somewhere, and then it would not do all the deploy. It would test in your running version. So it's starting MySQL. It has started MySQL. You see that's not too long. And it's rebuilding. In our case, we're actually rebuilding a custom version of XWiki for the testing, because we want to test a minimal XWiki for this test. This is what it does there. Then it's starting Tomcat here. And once that is done, it's going to provision some stuff for the test. So this is, okay, I'm running on the live latest version of the on Git here for XWiki. So there was a bug introduced yesterday with displaying some information, but it doesn't matter. So here, so this is provisioning stuff for the test. This is specific to XWiki, and now it's going to start the browser. So we've done the database, the servlet container, and the browser very soon, and the test will launch. So I will not wait till the end. You will see it after. It takes about, let's say, 2 minutes, I think, globally, to start all those containers, and then you get a result. And you get the result of pass or fail, but you also get something interesting. Is you get a video of what happened. Here, if I wanted, I could have put a breakpoint anywhere in the code, and then I could have used a VNC client to connect to the container running Selenium, and see exactly the screen, and then step by step see each action. But there is also a video done. So we see here it's done. It's done now, and it executed things, and here it says it passed the test but failed. That's because we have some validation, and since there were some things output on the console that were not normal, we failed it. But that's not related to configuration testing. So if we look at the video, I can open it, and this is what happened. So we see there is some navigation inside XWiki automatically, filling things where it goes a bit faster. You can't really see, but it doesn't matter. The point is, you get a video if you want to see what happened. You can debug manually, and you can also get a screenshot if something fails. You've got the screenshot at the moment of failing. Let's go back to the slides. So, why test containers? Because you could have done the same thing if you wanted with a Docker Java library. Now, the nice thing with test containers is that it provides a lot of built-in containers. So you don't need to invent how to do it. So what does it mean by built-in? It means that it knows how to start and stop them, knows when they are started, so that you don't need to do the waiting yourself, and they are configurable with all the parameters you want. So there's MySQL, Postgres, Elasticsearch, and Nginx, and Nginx, and a lot of others. So that's cool. The recording of video, you've seen that. That's quite nice. And what's really nice is that I was really afraid at the beginning that by doing this, we would get a lot of stray containers left running after the test. Like imagine you stop the test in mid-air. You know, how does it work? Do the container remain there in Docker? Do you need to remove them afterwards? Well, the nice thing is that TestContainers starts at the very beginning of TestContainers. It starts a container, a Reaper container, in charge of cleaning up all the other containers. And actually, it does that very well. And I've never had a single instance where it doesn't clean properly. So it does clean it properly, and you don't have any stray containers left after the test. That's really, really appreciable. So you can do anything, and in our case, we even build Docker images on the fly during the tests. So that's also possible and working well. So conclusion is, for us, since we've implemented that, we've been able to reproduce bugs that we found with different configuration. We found like about 10 bugs for about, let's say, 4 months of operations, with only a few tests converted to Docker, because we now need to convert all our previous element tests to this Docker-based test. And that's already very interesting results for us. We've also implemented support for Docker. Some people call it Docker inside Docker or Docker outside of Docker, because when you run this in your CI, imagine you're running in Jenkins, you may have the agents be Docker container themselves in your CI. So Jenkins starts a Docker container, and inside that Docker container, you've got your Maven build, for example, which itself run your functional tests, which themselves use Docker. So you need to be able to do that, and TestContainers does support it, so that works. And the other thing I was afraid of was the false positive due to all these containers being startup and synchronized and syncing, etc. And in practice, it seems to be quite stable and working quite well. So that's the good news. So in conclusion, if you have one takeaway from this, is that with TestContainers, you can do configuration testing right inside your IDE. And that's really awesome for developers, because that's really a hard part of debugging problems that happen in production. Thank you very much.